Welcome, everyone, to today's webcast, Collecting and Analyzing Logs in Hybrid Cloud Environments. I'm your host, Paul Asadoorian. Of course, joined by Mr. Matt Alderman, CEO of Security Weekly. Matt, welcome.
Good morning. It's nice and early in the Western time zone.
Yes. Hopefully everyone's hunkered down, likely working from home, tuned into the broadcast today. Of course, Corey Thune, the founder of Gravwell, is here with us. Corey, welcome.
Good morning. Very excited.
Yes, this is it's a lot of fun. It overlaps with some projects we're working on, as always, which is great. Like to overlap our content with things that we're actually doing, as we still are actually doing technical stuff, which is a lot of fun.
Yeah,
I love
that's
it.
what makes you guys a great show.
I love it.
Well,
so
at least you are, Paul.
yes. It's a lot of fun, and I get to talk about stuff that I've been working on, which is great. So just administrivia, of course, everyone gets all of the slides and the recording of this broadcast, so you can refer back to it. There are a couple things you might want to refer back to. So we'll start by talking about, first, just one very high-level, not technical slide, right? Talking about the various logging responsibilities, taking some of the perspective that we have on cloud and the different forms of cloud and where logging may fall. So we'll spend a little time discussing that. Then as you move things into the cloud in various capacities, what the question I had is like, what happens to my logs now? And I have some examples of things that I changed when I was doing some deployments. And now as the deployment changed yet again, I'm like, wow, how do I get all these logs together? And a lot of those answers will be in Corey's section, Collecting and Analyzing Logs in the hybrid cloud environment. And Corey will walk you through several slides on various aspects of collecting and analyzing logs. So let's jump into it and talk about who's responsible for logging in the cloud. When we look at on the far left, on-premise all the way to SaaS, right, and everything in between, how you do logging, what you're able to get in terms of logs definitely changes, right? If we look at on-premise, of course, you can get all of the logs from all of the things because you control all of those things, right? You can get the network logs, storage logs from your NAS devices, everything that's on-premise, right? You have complete control over the operating system, the hypervisor. All of those things have potential to generate logs. Whether they're interesting or not, or useful, is probably your mileage is going to vary on that point. I know here largely, monitoring for performance and security, there are a lot of overlap, and monitoring for operations and reliability and uptime is yet a different aspect. And we've done webcasts before. We were using Zabbix actually locally to collect a lot of those basically logs and make graphs. So we could see from the network side, like, is the network port is being overrun? Is there errors on the network port? All the way up through the operating system, all the way through the firewalls, all the way through the internet connection, and monitoring those things. And then, of course, controlling the network, you can put packet captures on there, collect those logs, NetFlow, and all those wonderful things. Now, some of those may translate into the cloud, especially with the infrastructure as a service. I still, I see in, AWS and other cloud providers provide that, right? But then as you go right, you start to lose, I think, a lot of those logs. I don't know, Matt or Corey, if you want to weigh in on the progression of, like, how do we lose some of those logs when we go to the right of this chart?
You certainly have to put in work to get them,
Yeah.
you can't rely on some of the old ways of doing things where you just throw syslog at a thing. It doesn't.
Right.
It's certainly more complicated when you get up in there. So understanding that environment and putting in the work, as you've seen, to make sure that you're configured and actually getting the data flowing is not nothing.
Yeah, this is where services have come in from the different cloud providers like CloudTrail and CloudWatch and other things to try to extract some of that data back out, Corey. But it's different than when you own the device or have control of the device. It's not the same. So now you have to rely on a cloud service to actually give you access to some of that data that you used to be able to get easier before.
Yeah, so getting raw logs is interesting. A lot of what I found too is it will give you the kind of high-level charting and graphing, right? But not necessarily the raw logs in a lot of cases, especially as we move to functions and true SaaS, right? You may get graphs and charts, right? But not the actual raw logs. So you have to learn to work with that in your operations. Now, what's interesting, when we look at a specific service, and I was looking at ECS, which is Amazon's Elastic Container Service, right? And what's interesting about this is it's not, I don't know if it's Kubernetes under the hood or not. I don't think it is. I think it's Amazon's own container orchestration platform, right? Very similar to Kubernetes in some aspects, in terms of being able to create clusters, define tasks, and having that CPU and compute and storage grow in the elastic sense, right? So that scalability, being able to deploy more services to handle an increased load, those types of features that are similar to what Kubernetes may offer are in ECS as well. Now, when I took my applications, in this case, it happens to be containers that are running MediaWiki, which I'm working on now to support our wiki. Those of you that have listened to the show for a while know we've maintained a wiki for many, many years that collects a lot of the metadata about our shows. And we're still using that today, and I was basically tired of maintaining it on basically infrastructure as a service, so I wanted to put it in containers. Now, when I put it in ECS, now we're not going to use ECS in production, largely because we can get it working, but then how do we operationalize it and build a CI/CD pipeline around it is probably another month or two of work to get to that point, and we'll probably transition off of that wiki at some point. So in the meantime, I was like, okay, we'll run an EC2, but I did an ECS test just to learn ECS, and I do like ECS for running your containers. But one of the things I saw in ECS was, I was like, oh yeah, how do I get my logs out of my containers when they're running in ECS? Now, when you configure ECS, whether you do that through the command line, which is on the top right of the slide, via the JSON configuration, or whether you're doing that in the graphical interface, you basically just tell it, some basic logging groups and enable CloudWatch configuration and the cloud log driver, which is AWS Logs. Now, when you do that, in this case in ECS specifically, your containers, their logs have to be sent to standard out. So on the bottom part of this screen, if you need to do that, there's some examples. This is two different containers. So the one on the left is my application server, which in this case is PHP FPM, because MediaWiki is based on PHP, unfortunately. And on the right is Nginx. And so this is the start.sh in each of those containers. And you'll see when I run these actual commands, it's very, very simple script, obviously. And I run the command, whether it's PHP or Nginx, and I basically forced standard error, right, as the logging output. So it's logging that out. And when that does that, that allows the CloudWatch service to grab those logs and put it in different places. So now when I'm taking this configuration and I'm deploying it out on EC2 just as a temporary measure to get us by, because we're going to phase this service out. The wiki will still live, and we'll talk about that at a later time. But in the meantime, now my logs are going to standard out, and I'm like, oh, that could be a problem. How do I grab them when I don't have a service? So that's kind of an interesting, as you use different cloud services, whether they're cloud native or whether you're deploying on containers or whether you're on EC2, all of these little things matter, and you may not be logging. You may be logging too much, like I was, or you may be logging nothing at all. So I was really glad we had this webcast, because when I looked at my configuration, I saw a line in there that was from debugging. And Corey, I'm sure you've seen this a million times, right? Where you're going from a development or testing environment, moving into production, and you forget that you've got extended debugging and very verbose logging enabled. So I made that mistake. And you can see in my Nginx config in the upper left-hand corner, I had that one little word in there called debug, which basically said send debug logs to standard out. So when anyone hits the web server that was running, including the AWS security scanner, which I thought was kind of interesting as well, I get very, 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 very verbose logs that are sent out to the console, which could be problematic. It could impact performance. It could fill up disk at some point, especially inside of containers. That can be a very easy thing to do, especially when you're deploying Docker containers, right? They're writing all of those layers of the container to the somewhere in /var, right? There's a directory path they're writing to. So you need to make sure you have enough space to store all of those layers. It's in the overlay directory.
You didn't pull any credentials out of there, did you, by accident?
No, credentials, I manage differently. I have a hack right now for managing credentials. Credentials are much better. There's much better management in ECS, and the credentials in EC2 are also different. So basically, you want to use cloud native services for managing your credentials, right? Whether that you're deploying your own vault, that's one option. In AWS, there's a few different options, right? You got Secrets Manager, you've got Certificate Manager, which we should be using, but we haven't made that progression yet. But that's all very important. And all services that you should configure, enable, and then turn logging on to have visibility into them. So actually,
make sure that those don't show up in the logs.
And make sure your credentials are not showing up in the logs. Yeah, that would be bad. So once you configure all that in ECS, you get some really cool graphs and kind of I actually thought that like Amazon built a similar style interface to a lot of the logging and log management solutions that are out there. So Corey, I think you have some insight into that and some of the differences, right? And not just AWS, but other cloud providers as well. But you do get some basic monitoring, right? CPU and memory utilization and networking, which is nice. And then you get the raw logs. Because I configured them correctly, you get the actual raw logs in your CloudWatch console. And you can see there we had security events. I mean, go figure. Don't ever put phpMyAdmin on any of your production environments because people are looking for it, as you can see as evidenced in the logs below. This was not even a production service. This was just a test service. It was exposed to the internet for testing purposes. And lo and behold, bots are out there looking for things. And if you did have something like phpMyAdmin configured, you might have gotten owned by some kind of automated bot, which is kind of interesting. I was able to see that in the logs, but I'm still not happy with our logging solution, which is why I'm very anxious to get Corey on to talk about the ways in which you can manage and analyze these logs, collect and analyze these logs, because we need to do a better job of that, and we're probably not the only ones.
Yeah, absolutely. Especially when you've got multiple cloud providers and you're trying to analyze all the stuff and try and make sense of everything that's happening as you're finding. So, it's gonna be fun. So you can hit. I suppose Paul. I don't know who's driving.
Yeah, that'd be me.
Paul driving.
Okay, cool. So I think as you illustrated with everything going on at Security Weekly, like a lot of people are moving stuff into cloud. We're taking advantage of the high availability. We don't have to cover the reasons why that is true. But I did want to add a little caveat and say, we're couching this discussion from the perspective of the security analysts, from people who are trying to figure this. If you're talking about it from a DevOps perspective, then things, it's a much sort of a different conversation. So we'll just couch that and say, some of the terminology we use might not be 100% right or whatever, but that's we're talking to the security use case for all this stuff. And so I think I put this slide in here because it's kind of fun to sort of go through the history and talk about how we centralize and decentralize, and we kind of swing back and forth between whether computing is powerful enough or too powerful that we need big rooms and 2-ton machines with vacuum tubes and and punch cards and cool stuff like that, where we get to personal computers, and then we're centralizing again in a virtualization cluster, and then you might argue that distributed computing like blockchain and mobile devices kind of swung it the other way, and now we're centralizing on cloud stuff. It's just kind of fun to think how things go back and forth throughout computing as hardware and software changes.
It's interesting. Today, most of us have a little bit of everything, right? Mm-hmm. Most of us have some presence in a cloud in some capacity. We've got stuff on premise, and we've got mobile computers, mobile devices and personal computers in our organizations today. And we just
most people are consumers of SaaS stuff that might be in the cloud as well. So I don't think we're really even going to touch on trying to get audit logs out of tools that you're getting, but like Office 365 as an example, right? That's not something you necessarily manage. You're relying on them to get the audit logs and everything off of that. So you need a separate ingester that just connects to their stuff. Mm-hmm. So that's an important consideration too, that we're kind of going to ignore for the purposes of this discussion. We're talking about infrastructure that you actually own and have actual control over.
Well, Corey, what I think is interesting, right, is we moved away from the mainframe to distributed virtualization, kind of brought things back together. But then the next layer of abstraction, containerization, started to spread things out again.
Right.
So it's not, you said it was hardware and software, but I mean, this abstraction has done things both to centralize and then turn around and decentralize our systems.
Yeah, well, some of the diagrams that we pull up later are going to be fun because it's and then when you start throwing containers in, man, I'll be really curious 60 years from now how many layers of abstraction we have. Nobody's going to know what's going on, but containers. I mean, containers have been around for a while. BSD jails was a thing for a long time, but yeah, the way that we're using technology to do some of this is a little crazy. But yeah, so I thought it'd be a good idea to talk about a couple common misconceptions that happen, and these seem true until you start getting into actually doing any of this. Paul, probably you can attest to this after you're having to fight with getting PHP running in Docker containers and everything. The first one is that a cloud, there is no cloud; it's just somebody else's computer. It's a common sticker, like I've seen this on laptops or whatever. And that kind of probably sort of was true in the very beginning, where really it was like you're just running a virtual machine on somebody else's infrastructure. But once you start getting into continuous integration, continuous deployment, containerization, ephemeral services, serverless architecture, all these things that we said we were going to kind of not do buzzword bingo here, then the cloud sort of matters. And the second misconception, one is one that I was totally guilty of.
On this, someone else's computer, you're absolutely right. In the beginning, that might have been true. But today, it's not just someone else's computer. It's someone else's services that are providing some of the basic and more advanced things. But when I look at it now, it's not just logging, right, is one thing that, you're going to utilize a service, not necessarily pull them from a computer, because that, CloudWatch is a service that you have to configure. Your elasticity, right, and auto scaling is a service that it's not really someone else's computer. There's software at Amazon that's allowing you to do all of that scaling, in addition to the networking, in addition to DNS, and then storage as well, and the different options that you have for storage. So it's not just a computer, it's really all of the components that you think about to architect your application can be pieced off into the cloud, right? And more as we move forward, I'm abstracting more of those layers off, right? I'm not just plopping my server up in the cloud. I'm basically looking at my architecture going, okay, how am I going to do storage? How am I going to do networking? How am I going to do logging? And how am I going to do all these things? And which services from which cloud providers am I going to use to do that? And that's really where I think we are today.
Well, and I think it's more than that. Yeah, but I think it is somebody else's computer, maybe somebody else's service, but there's still responsibilities I need to have as an organization to understand what's going on with those computers and services. And this is where the shared responsibility model has been confusing to a lot of people, Corey, about who owns which layers and who's responsible for what. At the end of the day, organizations still have to have some level of responsibility for monitoring that other computer, that other service potentially in order to make sure it's secure.
Absolutely. Not even just security, but uptime and things like that too. Because sometimes the provider...
And your bill, right?
Definitely your bill.
And the bill. So the second one was kind of like, this isn't necessarily fair to these guys. I just pulled this off of Google. I'm not connected to them fully, but he looks pretty happy. He's going to talk about cloud computing and everything, and isn't using somebody else's computer simple. But on the next slide, I think we can see that no.
Yeah.
All you got to do is go to the menus, like you guys were just talking about. These are the menus from GCP, AWS, Azure. No, I mean, there's so many services and things that you have to do to set up identity access, the virtual network, everything that we just talked about for the abstraction layers and services that are piled up together.
But Corey, isn't it just infrastructure as code now? You don't need to use these menus. You just build a configuration file.
Yeah. Well, actually, maybe we'll hit on that a little bit later because hopefully, maybe, but I fully confess I was guilty of this myself, and trying to set up environments and things just to demo out this exact kind of thing that we're talking about, where I'm going to collect logs from this mock environment or whatever. I did not anticipate the difficulty of doing that in one provider, let alone three. To try and figure this out. So it's not a super simple, super straightforward thing. DevOps people are smart people. They do good things. The people who are managing your infrastructure, that job is not easy. So I think that's something as security that we're sort of guilty at in general, is we pretend like we know everything, and it's easy to get a little bit of a superiority complex when you see people do things like include credentials in their logs, or unauthenticated API controls to completely RM-RF your disk. But those jobs aren't easy, so there's a reason why that's hard.
Well, because the DevOps team has to try to figure out how to integrate and use all these services to work together. And you just said it, they're so complex that and Amazon just keeps adding more and more and more every day, and it only adds to the complexity. So when you think about how you set up or configure all these different services to work together, as Paul knows, you're going to make mistakes, right? You're going to log something you don't expect to log, even if you can get your logs out. They're not even thinking about the logging side of this when they're doing the initial setup. They're just trying to get the things to work.
Right.
Yeah, and more my advice for the audience today is to spend, when you're looking at deploying any type of your own services or infrastructure in the cloud or applications, spend a lot of time in the planning and designing stage. I think we've spent more time in those stages than actually coding, right? And that's super important, because you're going to think about all of the ways these things link together and set yourself up for success, rather than going in and making a whole bunch of mistakes and trying to do it like the way, like hacking at it is not the way to do it, right? Have a plan, spend some time reading, learning what each of the services do, how you might utilize them. I think that takes you more quickly to being able to configure infrastructure as code and use terraforming and cloud transformation as they exist in the different cloud providers, rather than trying to dig through the GUI and do it that way, right? If you plan and design it out, you'll be much more likely to be automating that creation of infrastructure, which I think is really the true power, right?
Yeah, using their CLI I think is better, but hopefully that's kind of old hat to people. Maybe that's not a misconception that people deal with, and hopefully it's just me. But I suspect that it's not. So let's just rip through.
Corey, before you go to the next one, we did get some audience feedback. Like always, the key of responsibility in the cloud will be established in the contract. Maybe contracts get interesting, I think, in the cloud providers on who is responsible for what. And I know a lot of people have a when you look at some of those contracts, they're pretty complex too. So
Yeah.
Just word of caution. You will get some guidance there, but then there's also things that you're not going to get flexibility on either from some of your cloud providers. So I hear you. Some things are in the contract, but some things aren't that easy to find in the contract either.
Yes. So if we talk about the different cloud providers, so AWS has they have CloudWatch, which kind of acts as a brokering system for all this stuff, like you showed with your containers. You can specify the log driver in Docker and then set it up, and you just kind of connect it to AWS CloudWatch, and then the events show up in there. And this is true for pretty much all providers. They're going to have some brokering layer or a data bus layer style service to collect those logs, because running an agent on each of your virtual machines in the cloud is not really tenable.
Corey, CloudWatch is applicable to all of or most of Amazon's services, correct? Like,
yes.
What I've noticed is, like, when you pick and choose which services you're using and progress deeper into Amazon's cloud, CloudWatch is a thing that kind of follows you around and lets you collect what's happening collectively in AWS, which is nice.
Absolutely. And that's true for all of them. CloudTrail feeds into CloudWatch as an example. So this is pretty much a standard pattern where you've got that data bus layer and then an auditing API that maybe feeds it for how they're doing. There's just an example AWS entry on the side, but you can audit, who's hitting your endpoints, who's logging into the controller, who's using the CLI, what they're doing, that kind of a thing.
Yeah.
So this is so as a security team, you definitely want the audit logs, regardless, so you can see who's standing stuff up and messing with the infrastructure, and then the application logs are going to come through CloudWatch. And also pretty universal to these is this logging agent can be run as a standalone in a server. So if you've even got bare metal, you can run this and it'll collect up your logs, ship them up, and connect into the cloud too. So that opens up some options for us when we start talking about architecture strategies later in terms of what we can do. So the next one is Azure. Pretty much works the same. I just wanted to hit a little bit on some of the background. They used to call it Azure Data Explorer, which is built on top of Kusto, and this uses more of not an SQL style language, but it's its own query language for how they're doing some of this stuff. It's got some structured and relational things in it, kind of cool, but works a little bit differently. And then they have sort of an equivalent for Lambda functions when you're connecting to things. I'm not going to get too much into individual providers, but later when we get into the architecture diagrams, we'll talk about those parts. And then so GCP is next, and they use Stackdriver is their they call it GC Operations, Google Cloud Operations Suite now. That's sort of the same thing. They collect the metrics, log events, application performance, and then they can ship on-prem to cloud. And then it follows. They have a sort of a defined structure that's got a metadata wrapper around whatever your raw data is, and then that gets thrown into there, and easily goes into different areas of GCP, which we'll hit in the upcoming diagrams. So let's dive into the architecture planning itself. So our general goals for logging is I'm always going to lean toward let's log as much as we can, and then once it's getting in, then we can sort of figure out what we can filter out using either lambdas or built-in filter functions to each individual provider in order to decide where things go. But we want to keep what we can, because if you're not collecting it, then you can't analyze it or benefit from having any of that information. The other thing is we want to preserve the original format as much as we can, because anytime you translate or normalize, that by definition is data loss. Even in human language, we lose nuance with words when you move from German to English or such a thing. The same is true for data. When you're moving data around, you're losing things, which makes root cause analysis harder. It generally complicates the analytics process. So we want to try and keep the original format. We also want to support additional teams. As a security team, we kind of get to be the sort of the oracle in the sky, or the the one central place for all information, because generally security touches everything. And so if we can have all of our logs in one spot, that's great. But other teams need this. If you've got a DevOps team who's responsible for something in Azure, they're going to want to be able to get in and see some of these logs. They want to see the application logs. Maybe your marketing team wants to see the output of some of these logs, that you can provide them with some dashboards or analytics to help them do their job better, right? So we generally want to enable those types of people to also benefit from this information. And then finally, we want to be mindful of the log location and separation for compliance and potential money saving. Like, we want to be conscious of some of this budget stuff and where things are at, because that's always a conversation about when you're doing logging, storage, compute in the cloud. Is budget gets a little unpredictable, so we want to try and keep that as predictable as possible. And those are our general goals for what we're trying to do as in looking at this. So just a little bit more to that point of the cost. Generally, you don't get charged for putting data in, aside from storage. But taking data out is potentially a lot of money. But I have a confession: I didn't do the math. But in talking with people who definitely use these things, they said it's expensive. You don't have to do the math.
Actually, I have a spreadsheet for that, as Paul knows.
Mm-hmm.
Your bandwidth costs can add up pretty quickly when you start moving data outside of the cloud providers.
Yeah, it gets silly.
Storage is cheap.
So we'll just skip over that. So let's go to the next one, and let's look at our general architecture. So we're going to use sort of a mock environment here, where we're going to have compute in GCP, AWS, Azure, and then some on-prem stuff. And so we've got the different services running. Those, I just put cubes there, very abstracted, to say here is some service that you've got running, because that's not necessarily the focus. We want to focus on the data coming out of this stuff. And then we've got some on-prem stuff. So if we walk through this, if we've got some services running in AWS, we're going to use CloudWatch, kind of like Paul already showed. We're going to feed that into the all those CloudWatches feed into the centralized CloudWatch, and then CloudTrail can feed CloudWatch. And so we've got our logs using AWS. We can take advantage of their services and the excellent work they've done to collect all that information in one spot. And then very similar in GCP, we're going to use Stackdriver to get that into one spot there in a centralized bus, and then Azure Monitor in the Azure system. On-prem, things get a little more complicated, but this is all stuff that we have experience with. We know how to use syslog. We know how to collect application logs using agents or Elastic Beats or whatever. We've got network flow information. We've got DNS logs and stuff. What I did here is one of the things that we kind of advocate where possible is to follow sort of that model that they've done in the cloud, where we have that centralized event bus, and that's what Kafka represents in this diagram, where instead of having a bunch of agents sprinkled around and collecting and all forwarding to various logging sources or whatever we're going to do, if we can set them up to use an agnostic bus, then that enables us to more easily decide where that data is going to go. And so you can hook up one analytics provider and say you don't like that, or you want to swap it out. You're not vendor locked in. If that makes sense, because if you deploy a specific agent a bunch of different places, that's a non-trivial task, and so it makes it hard to be more flexible with how you're handling your data events and everything.
Now, Corey, what is Kafka?
Kafka is I believe Amazon Kinesis is based off of Kafka. Mm-hmm. Don't quote me on that, I suppose, but I think that's true. But it's an Apache project. It's a data bus. Pub subscribe, message passing bus, sort of a general way to people can just put stuff in, and it handles like sharding that out and putting it in a bunch of different areas of the cluster, and then you can request the events out, and it'll keep the events around so multiple subscribers can get the events, and it keeps them in basically kind of a ring buffer distributed. That's a very a simple way of putting it. But yeah, it's great for doing the message passing bus.
It's awesome.
Yeah, if you've never played with it, it's pretty sweet. But I'm pretty sure that's a lot of what people are using in these different cloud providers for moving stuff around anyway. I believe Kinesis is based on it, but it's great for that. So sort of as a best practice, if you can get to that on your on-prem, then that's great. But often people are dealing with legacy systems. So in this example, we're going to play with it, having Kafka there, and some data you don't want to put in there because of the nature of things like NetFlow. You'd probably have to encode and drop it in. But that's what we're going to be talking about for the architecture. So this is kind of the environment that we're playing with. And when we think about architecture, how do we log all this? How do we get that guy in the SOC or the team of ladies and gentlemen who their responsibility is, how do I know what the hell any of this is doing? How do we get them connected up and ready to rock? And in doing so, we've got 5 different options, which is the next slide. So number 1, we can do nothing, of course, which unfortunately is forced upon us in many situations. Number 2 is we can collect and store in kind of a break glass in case of incident type of situation where maybe we don't have the cycles or the team to get in and do stuff, but at least we have them. We can use built-in analytics by the provider. We can pick our favorite provider, send all our logs there, or we can deploy an agnostic solution to each provider and try and do it that way. So we'll walk through each of these.
The nice part about number 1 is I don't suffer from alert fatigue.
True.
That's true.
You also don't have any idea what's going on.
Uh-huh. Yeah. There's knowing things definitely breeds paranoia.
Yeah.
If anybody's not looked at logs and then you open them up, yeah, exactly. Like if you've never looked at your PHP logs, then you look at it and it's PHP Mayan all over the place.
Mm-hmm.
Like, oh,
Well, if you're doing compliance, check the box where you have to collect the log and store the log. It doesn't say you have to look at the log.
Right. That's number
Right.
2. And
That's number 2.
You would
That's
not suffer from alert fatigue there either.
Correct.
Until you break
so that's
the
the
glass.
advantage of some of those. But yeah, so if we skip forward, let's just walk through each of them. Let's walk through each of them together. So number 1 is the classic. Everything's on fire, but we're just going to pretend that if you don't know, then it doesn't matter if it's on fire.
But I mean,
it does.
Eventually you'll get burned and inhale a lot of smoke, right? Because what happens is there will be an event, and you're gonna go, oh, where are my logs? How do I see and figure out what is it the bad push of software? Is it some external attack? Is it an internal attack? Is it just performance load? Is it denial of service attack? Intentional or unintentional by an internal user, right? You can't answer any of those questions if you're not doing anything and gaining visibility.
Right. Yep. Absolutely. And so that's an important point on number 1. I think that's probably the end of the discussion because we all agree that that's maybe not. So if we go to number 2, and at first glance, it seems like this is a bad, this is as equally bad as number 1, but that's not true in reality. Because so here we're going to cross out the SOC because there is no SOC. That's just Jack. And Jack's responsible for this. Mm-hmm. And Jack has a lot of shit to do. So he's not, we can't really be worried about all this stuff. But if there is an incident, we want to at least be able to look, right? Mm-hmm. For compliance reasons and for personal peace of mind, various things that say, if somebody does need to look at something, I have the capability.
Right.
That's what we want to enable. So we call this incident response readiness. The idea that that at least you are ready and you can break the glass in case that you have something. Because you guys talk to lots of IR folks. How many of them roll up on a site and there's just nothing? Mm-hmm. And so then they start collecting when they show up after the attacker's already there and done whatever the hell they need to do. That is not the situation you want to be in. 100%. You need to be collecting the logs as they happen because obviously once an attacker's there, you can't trust anything that's going on anymore. Or it's very difficult, at least in the cloud. Generally an attacker who does manage to gain your infrastructure isn't going to be compromising cloud
And what I've seen in this particular instance as well, Corey, is there's obviously a lack of operationalizing the logs, right, in events.
Right.
And
Yep.
what I've seen is the attempts at doing that, like, hey, we're at this point in our architecture, design, and systems, and there's some operationalizing of the events and logs that are being generated, but then the systems and architecture changes. Jack gets really busy, and he's like, well, now I'm just collecting and storing. I'm not, I've lost a lot out of my console that I was using. It expired. It's maybe based on open source, and I haven't updated it, so I shut it down because I've got other projects to work on as well.
Mm-hmm. Yep, exactly. And that's a challenge, and especially for, this is a problem that's pretty passionate for us here at the team, because we want, like, this is a good first step. There's tons of companies who are in this position where they don't have the resources. So you want to be able to just get that data in somewhere, and I'll hit on this a little bit more. But this is not a bad thing for Jack to be in. Like, this is the best as Jack is going to do, and that's not. We shouldn't lambast him for that position. So the different providers have different long-term, very cheap storage that you can do, where you can keep those logs around for a long time. Because if you try and keep the logs around just in their initial, if you keep it in the analytics that they've got built in, there's usually the retention is like 30 days or maybe more, but it starts to get expensive. So if you can set up like a Lambda function in AWS to shove that in S3 or move the S3 buckets into Glacier, that can reduce your cost significantly. And that's not nothing. That's work to get all this stuff set up. But I think it's a good first step. If you don't anticipate, you didn't set up a project where you say, here's our budget and we're definitely going to get to this point. We know that we've committed to it. If you're growing in this area, it's a great way to, I think it's worth the investment. Even though it seems like you're not getting benefit out of it, you're just keeping the logs around. Still very important if you end up having an incident, or developers or something need help to be able to pull the logs and help them out. And then on-prem, we've got like a big ass NAS is what I call. That'll come back a couple times, but
yeah, that's cheaper than a big ass SAN.
Yeah.
True.
I'll confess, I don't get to. I use the terms interchangeably. I don't know. I know I'm not supposed to, but I do. Big ass storage. That's where we'll use a generic term. So option number 3 is where we use provider specific architecture. And so this is where like you were doing or showing where in AWS we're going to use their built-in analytics and monitoring. GCP has the same, Azure has the same, and then we might have something on-prem, whether it's Gravwell, Elastic, Splunk, something.
Yeah, and this is sort of where I'm at now, right? Like in AWS for certain services, I've configured the log, and which was easy as like, when I deploy something, I check a few buttons for Cloud Watch, and then I maybe tag some resources, right, in things that I'm using. And if I do that, I can use the analytics console in AWS as an example to do some basic analytics. Now, I don't know I haven't dug into it enough to know what some of the differences are, Corey, and that's kind of my question, between these analytics dashboards and what I can get either open source or commercial to help me analyze that data. I'm assuming there's probably a pretty big feature mismatch.
Yeah, in some ways, especially. So let's hit on that in 2 ways. So first, generally the provider stuff is they're relatively equal with each other. The advantage is they've built these analytics for their exact structure and infrastructure. So they can do some very specific things. It's the difference between an adjustable wrench and a sized wrench. You can do more torque with a sized wrench than you can an adjustable wrench just by nature of the tool.
Right.
But it's less flexible. So they have it set up for that. And then to your question, where we start talking about open source tools or like alternate logging platforms like Splunk or Gravwell, that kind of gets you into the discussion about sort of the underlying data store and whether you're using an unstructured data lake versus a structured data store and how you're storing that. That affects your flexibility and being able to look at the different logs kind of gets back to that initial goal that we had, which was we want to preserve the log formats in their original format as much as possible. Mm-hmm. And so if you set up something like a QRadar or something like that, where you're going to put these events in, there's going to be some normalization and some predefined structures that you've got to do versus a Gravwell or Splunk, where you just spit events at it and sort it out later. Like the parsing or breakout kind of happens at search time instead of ingest time, which makes it significantly easier to put data in as well. So we'll kind of get into that in actually the next couple diagrams, but that's an important point when we're talking about the provider-specific stuff. Is it's purpose-built for them. So if you because you can take GCP logs or AWS logs and put them in GCP. You can take GCP events and put them in Azure, but you're not going to be able to use, like, the analytics tools are going to be rough. Yeah. Right?
And that's also expertise, too. You know, I was talking to someone that works at a very large corporation, and they use one of the very large logging providers that you've mentioned, Corey, right? And there's a full-time person for even just like one aspect of collecting logs for a certain purpose and putting them in QRadar, Splunk, right? And providing analytics. And that's a full-time position in large corporations, right? And so now you've mapped that out, and now you've got, 4 of them. How do you map that expertise, right?
Right,
and you have those cycles on your team to do it, right? Go back to your example of there's just Jack, right?
Mm-hmm. Yep. So I think we'll hit on that a little bit more. Let's go to number 4, which is our single provider as the chosen one. So let's say your team is super happy with Azure. They really like the analytics there or something. I mean, you can use Azure Monitor as an agent to feed it data from the different clouds and on-prem. But getting to that point, like then you're using a structured data store for data that it wasn't structured for, which gets you into potentially rough shape for trying to analyze that. You've got to deal with all the ways that you're supposed to do things or expected to do things on unexpected data. And that's generally a recipe for inflexibility and some potential problems. But it does mean that your SOC only goes to one place. They're not in their chair swiveling around metaphorically looking at a bunch of different interfaces. They've got one. So there's give and take for how that operates.
Yeah, and we've seen this play out, Corey, over the years with different integrations into the existing SIM providers, right? And using something like the common event format, Ceph, to try to shove everything in. There is some contextual data you lose in that model, but at least everything's in one place. So there are pros and cons, right?
Yeah, that's a great example. Yeah, exactly. You take an event, you turn it into Ceph. You're losing some information about it. But sometimes that's I accept this risk, or I accept this reality is certainly a valid answer to somebody announcing a vulnerability or the trade-offs between two things. So if we go to number 5, and this is obviously I'm biased because this is literally what we built our tool to do. But the unified logging architecture is something that I think we can do. This doesn't have to be a pie in the sky thing. And there are ways that we can do this today. So how we can deploy is you can stick in analytics, centralized analytics in each of these providers. And this is true for other solutions as well, right? If I want to stick an Elastic cluster in each of these, and I want to feed the logs in the events into Elastic instead of using the built-in analytics, then I get some benefits from that. Namely, I get control over how that data flows in. I get control over the retention policies, age-out policies, all that stuff. I get to be able to do that.
So I think this is starting to answer the audience question that's out there now is, could you demonstrate how Jack would use the aggregated logs, for example, how to query, report, and share data sets? I think this is exactly where we're going now is if that SOC is really Jack, now he's able to aggregate all of those logs and start to query and report on all of them.
Right. Yeah. Let's say if you've got the same application running in different cloud providers, then when you're issuing your search to do this, the applications, let's say we're not normalizing, then you're going to have different metadata from different things. So you'll have your Azure metadata, you'll have your AWS metadata, but then you've got your raw log. So you need to do some general extraction on each of those flows, and then you can join them together to create that data fusion layer of my raw event coming out of the application.
Right.
And then and fuse that and analyze that just as if all that was in one spot. And, it was a single server and I've got my events coming off of there. That's the whole point of creating this sort of window into the different providers at the same time, is then with a single query, I can hit both of these data stores and the events coming out of both of the providers. And so, but there's some important requirements related to this. For Gravwell, we call this Overwatch, which is sort of our multi-tenancy setup. And so it's going to be common. You'll probably have a team, like if you're deploying into Azure, there's probably a team that's responsible for that infrastructure or those services. And so they need to be able to do analytics and things within there. But they might not necessarily need access to GCP, or maybe you purposely don't want them to have access to GCP resources, type of a thing. And so by utilizing, multi-tenancy practices and principle of least privilege separation, kind of taking that zero trust model, trust but verify type of a thing, however you want to, couch it in the terminology there, you want to be able to have the SOC be able to query this different stuff, and then the individual teams still be able to use these analytics and benefit from this unification.
Right. So in order to do that. As Jack, I can normalize on event. In other words, bad user login or whatever, right? That's going to look different across all of my sources, but I'm going to normalize that event down to there was a bad user login. Doesn't matter where the application was deployed, there was a bad user login. Right. I still have the details in the raw logs, but I can normalize up to that event to say there was a bad user login, for example.
Yeah, exactly. And I believe this is only true for really, you're going to benefit from it if you use something like Splunk or Gravwell, where it is unstructured by nature when it hits the store, because then you don't do that normalization until query time instead of at search time.
Gotcha.
And so the translation or the loss of data doesn't happen until you know that you don't care about what you're throwing away.
Right.
So that part I think is pretty important when you're talking, like the more we add for this weird different types of events and the more we need to fuse them as sort of a centralized, somebody, I did see an unusual number of logins to my cloud provider, as an example, right? Which provider is that? If I want to track, my team's hitting the different providers and usage and stuff, the audit logs of some of this, I want to be able to fuse that and normalize that at query time. So that way I can always go back to the root cause, because if I see something sitting up in, if I see a problem in one of the providers, I want to be able to go in and talk to the individual team and resolve the issue.
Corey, I assume the other advantage of this architecture is I don't necessarily have to move logs now, right? That I can keep the raw log data in these different sources, not necessarily have to move them, which would incur potentially a lot of bandwidth costs to move them. Is that true?
Absolutely. Yep. That's actually a great insight. And that's why it's a little tough to see on this, but that's why the lines from the SOC to the different providers are blue, and they go both ways, because really we're not transmitting data, we're transmitting the results of our queries, if that makes sense.
So the SOC, so in this case, the SOC can query across all the stores, only bring the results back, and not have to move all the raw logs into like this huge data lake and incur all this cost of moving all that log.
Exactly.
Data.
Yep, your data lakes. So instead, you've basically got 4 data lakes that you're able to query all at the same time, which is super powerful and awesome. Really flexible. Enables all kinds of really cool stuff. So I mean, that's what we're excited about.
That's great.
And that enables, because then you've got that the power within the single tool. You're not having to go to each individual provider and whatnot. It does complicate the infrastructure a little bit if you're just using the provider tools and you're logging into their interface. That's easy. It doesn't require setup. You're not standing up your own data lakes within the environments, but that's the trade-off. Right.
Corey, just FYI, we have about 5 minutes left.
Mm-hmm. Okay.
And I know you probably got a
so let's we'll hit this. Just revisiting Jack. In that same way, you can apply that long-term storage and still keep your analytics in each of these, and then use kind of just in time to thaw that data out from those long-term archival stores, load it up into analytics if you have an incident, and do that. So this is one thing that I think we really do well for incident response readiness, because we don't charge based on how much data you put in. So for something like this, where you're just like, I don't need a lot of compute. Like, just give me one node, and then I'm just going to stick a shitload of storage on it so I can keep my logs forever. That's great. That's what we want to enable. We want to help Jack to be able to do that. So that's just another caveat. If you're choosing an analytics thing, that's an important aspect to the pricing model.
You don't want to take the cost hit twice. You're going to pay whatever charges are in the cloud provider, but you're not going to incur a lot more charges when you go to your analytics solution, right? Should be your requirements.
Okay, so so reviewing the benefits, that was what we wanted to do. They got Overwatch capability. The logs are in their original format. We want to enable, QA, DevOps, different teams to get in, and we don't want to move the data if we can. And I think this sort of helps us do that. You can go to the next one, let's talk about Kubernetes for a minute or so. Yeah, we've got another minute here. So kind of that pendulum. Go to the next one here, because we've got these articles that talk about this, and centralizing, decentralizing, and all these providers support Kubernetes now for how you're going to do stuff. So whether you've got all your own hardware and you kind of create your own cloud with Kubernetes, and then maybe you also use Azure or AWS, it's kind of enabling all kinds of crazy stuff. So let's talk about logging real quick with Kubernetes. We're going to do a very detailed technical deep dive into this later on. At a different date, but you use what are called sidecar containers. And so there's kind of two ways to do it. You either create a streaming container that dumps it to a log, and then you're going to read that log out and send it into your logging backend, or the next slide, where you use that sidecar container to actually be your logging agent. So this sidecar container could be AWS logging agent, or it could be a Gravwell ingester or Elastic Beats or whatever.
What I think is interesting about this, Corey, is this is actually a really good use case for sidecars. I've seen people attempt to use sidecars in different ways that I think create some really interesting performance issues. But when you think about from a logging perspective and using it as a collector, it's actually a very good use case for sidecars.
Yeah, yep, absolutely. So Kubernetes is awesome. I'm excited to talk about that more. But yeah, if we jump into the next one, there's just two more slides here real quick. So we reviewed the goals, but then you can do the next one, and then actually let's just go to the next one for a final extra 2 cents. So I think, like with Spider-Man, with great logging comes great responsibility. Our security teams should do a better job to work with everybody else. It's my personal opinion, because we're all on the same team. And you were talking about it on the show earlier today that I was just watching before we jumped on. But you've got these silos at different organizations, right? We want to try and, I think, as an industry, if we can break down those silos and be more inclusive and helpful, I think that would help us all sort of just do better. And then I had just another thing that is totally a side rail, but just a comment that I saw saying that security companies at the moment are sales driven, not product driven. That's just my own personal, as a founder, that hits home. So those are the extra non-logging related things. So if we go to the next one, that's the final slide. Hopefully this was, it was great talking with you guys through, cloud logging, seeing how you're doing things at Security Weekly and everything that you've got set up. We're going to try and do another kind of deep dive into Kubernetes logging on April 15th. If you want to get in on that, come in to the Gravwell page, and you can subscribe to the blogger newsletter, and we'll have more information coming.
Sweet. Corey, that was great. Thank you so much. Any final questions, please type them in the chat. If we don't get to your question because we're a little short on time, make sure you put it in there, and we will collect all of the questions and feedback and make sure that they get routed to the appropriate person. Corey and Matt, thank you so much for your time today and great information. Kubernetes is my next project I want to delve into. It's really I've heard a lot of kind of mixed things about it, actually. It sounds like you're having good experiences with it, Corey.
Yeah, I'm a fan.
Awesome. So thank you everyone for listening and watching, and check your inboxes for a link to the slides and video so you can refer back to them. Thanks again, everyone. We'll see you next time.